Okay, let's unpack this. Have you ever paused, while you're talking to a smart device
Yeah.
and wondered if it actually understands you?
Or is it just incredibly good at faking it, mimicking understanding?
Exactly. That feeling. Today, we're diving deep into one of the absolute classic questions in artificial intelligence, the Turing test.
Ah, yes, the big one.
Can a machine really fool you into thinking it's human?
It's fascinating, isn't it? Because this question, it really goes straight back to Alan Turing's, well, groundbreaking 1950 paper, Computing Machinery and Intelligence.
Right.
He sort of cut through all the philosophical arguments about can machines think?
How do you do that?
By proposing this imitation game, it wasn't about internal states, it was about behavior. Could it act like a human in conversation?
Okay, so our mission today, our deep dive, is really to explore what Turing originally meant, and see what that tells us about all the AI breakthroughs happening right now.
Been critically asked, I think.
Yeah, critically ask, if a machine does pass this test, does that really mean it's smart, like a human,
Mm-hmm.
or is it something else?
Right. What does passing actually signify?
So here's where it gets really interesting. Turing's original imitation game. Could you maybe sketch that out?
Sure. So you have a human judge, and they're interacting, usually via typed text, right? With two contestants they can't see.
Okay, hidden contestants.
Hidden contestants. One's a computer, the other is a real human.
And the machine's goal.
The machine's goal is simple. Convince the judge that it's the human, fool them.
We see this all the time in science fiction, don't we? Like HAL or C-3PO. They'd pass this easily, presumably.
Oh, absolutely. They're depicted as having general intelligence, way beyond just text chat. But that brings up a really crucial point.
What's that?
What exactly did Turing mean by thinking or intelligence for this test? People often miss this.
Right, it wasn't about, like, writing a symphony or proving theorems.
Not at all. He was focused purely on conversational indistinguishability. That's the key phrase.
So if you, the judge, couldn't tell the difference after a decent conversation.
Then for the purpose of that specific test, the machine had passed. It was behaviorally indistinguishable in that context.
Okay, so where are we now with that? You hear people like Ray Kurzweil making predictions.
Yeah, Kurzweil's quite bullish on it. He predicts a computer will pass a properly designed Turing test by 2029, which isn't far off.
That is soon. But
Mm-hmm.
does sounding human mean it is intelligent in the way we think about it? Because look at actual attempts.
Ah, right. The real-world examples are often quite revealing.
Like Eugene Guzman back in 2014, the chatbot pretending to be a Ukrainian teenager.
Yes, that's a famous one. It fooled a decent chunk of the judges, about a third, I think.
But they weren't exactly AI experts, were they?
No, they weren't. And many argued that Guzman's success said more about, well, human gullibility and the test's limitations than actual machine intelligence.
It exploited loopholes, like pretending English wasn't its first language.
Exactly. And even way back, think about ELIZA in the 60s. A very simple program, basically just reflecting your own statements back as questions.
And people poured their hearts out to it, believed it understood them.
It shows how easily we can be convinced by mimicry, which ties into what a lot of AI researchers are saying now.
Like who?
Well, people like Gary Marcus, Rodney Brooks, they argue that despite these incredible leaps, especially with deep learning,
The tech behind things like ChatGPT.
right, those big neural networks, large language models, despite how impressive they seem, Marcus and Brooks would say we've made almost no progress towards real human-level intelligence, AGI.
So they're good mimics, good pattern spotters.
Extremely good. They excel at statistical pattern recognition, finding connections in vast amounts of data. That's what deep learning does.
But not common sense.
Often lacking, yes. Genuine common sense reasoning, understanding context, causality, that's different.
Barbara Gross made a similar point, didn't she? About deep learning's success being down to its mathematical flexibility.
Precisely. It's flexible maths, finding patterns. It's not necessarily deeper thinking in a human way.
So things like counterfactuals. Thinking what if.
That's a big challenge, understanding the purpose behind language, not just predicting the next word. These systems are trained on data of what is, not necessarily what could be or why.
It's interesting. Turing himself kind of anticipated some of this, didn't he? He talked about maybe building a child brain machine and teaching it.
He did. It's quite prescient, like some modern machine learning approaches. but the analogy only goes so far.
Because real children aren't blank slates.
Exactly. We now know human babies come equipped with a lot more innate structure, ways of learning, understanding basic physics, social cues. It's not just data absorption, it's building models of the world.
Okay, so wrapping this up, where does this leave us with AI? We see these machines doing incredibly complex things. They write, they code, they chat, sometimes alarmingly well.
They certainly do. The performance is undeniable in specific tasks.
But is that intelligence? Is mastering mimicry the same as genuine understanding?
That's the multi-billion-dollar question, isn't it? Is intelligence just about perfectly faking it, or is it something, deeper?
Like real understanding, abstraction, actual common sense.
Reasoning beyond just matching patterns. What does smart truly mean if it's not just about fooling us? Maybe it's about genuinely knowing, creating, adapting, understanding the world, not just the words.
A lot to think about there.
Mhm.
Definitely something to ponder next time you talk to your smart assistant.